So the next step is really just to get some of the basic rules down. Some of them we've talked about a little bit already. We're kind of inversing or doing the inverse process of finding differentiation. So if you can remember all your rules of differentiation, we kind of just have to backtrack a little bit. So in this particular case, the inverse nature of integration and differentiation can be used to find some rules for differentiation, and there's some of them you just must know, and I've written out a few steps to sort of prove it to yourself. I'm not going to do all of the rules of integration, but you just have to know them. So this is the perfect timing for having another mastery quiz on the horizon, so just keep that in mind when we do this. In this particular case, if I want the antiderivative of f prime of x with respect to x, so here we're taking the variable integration here, I end up with f of x plus the constant c, so the constant of integration. So if I have this, then I also know that if I'm taking the derivative of the antiderivative of f of x, then I should end up with just f of x, because these two are inverse operations of each other. So it's much like, so I tried to put this analogy in here, it's much like division and multiplication. They kind of counteract one another. So it's the same with integration and differentiation. So if you read through the process we call dividing, you know that the mathematical notation for division can be written like this. You could also have a division symbol, but in this case, just for simplicity, we have 10 over 2 is equal to x. That means 10 divided by 2 is equal to x, which means we are finding a number x such that if I took 2 times x, it has to equal 10. So in other words, x is equal to 5 because I know 2 times 5 is equal to 10. So x, by the way, is called the quotient, and 10 over 2 is called a fraction. Just some terminology review here. If we do something similar, but think of integration as the inverse of differentiation, in this particular case here, we just picked a times x squared dx is equal to some function, capital F of x. The integral of the function ax squared with respect to the variable x equals f of x, which then means I can find a function f of x such that if I took the derivative of that function, it should give me this guy in here. So I need to find that particular function, f of x. So if I took f of x, and here we have it all set up for you here. A is some constant. So in this particular case, if I take 3 times a over 3, so if I took this and put in the denominator here, I end up with a. And then remember, we have to subtract 1 from the exponent when we take a derivative. So that ends up with ax squared here. And when I take the derivative of c, it's just equal to 0. So in that case, it's plus 0 in the end. So this works. So I know that this is going to be the antiderivative, or the general antiderivative, or general solution, whichever way you want to put that, of this particular function. So f of x is called an antiderivative, and this whole thing is called an indefinite integral, or an integral. Okay, so what I want to do is just establish some basic rules. And I think I'm going to have to do that in the next video, so moving on.